Hey everyone, and welcome to This Explainer. Today, I am super excited to step into the role of your digital mentor. We're going to chart a course from your university studies all the way through those incredibly critical first 2 years as a civil engineer. You know, civil engineering is so much more than just throwing on a hard hat and pouring concrete. It's about leading in high-tech corporate offices, pushing boundaries in research labs, and managing massive industrial environments. It's literally the field that builds our future, and I'm going to walk you through exactly how to master it.
Look, right now we're staring down a massive global shortage of civil engineers. According to the industry leaders we sourced, demand has completely outpaced the talent supply. The old guard is retiring faster than new grads can replace them. So what does that actually mean for you? Well, it means serious upward pressure on salaries and pretty incredible job security. If you navigate this correctly from day one, it's an absolutely lucrative and high-impact career path.
Here's our blueprint for today. We're going to cover the academic roadmap, acing those campus placements, choosing your career path, navigating those crucial first 2 years, and finally, global salaries and trends. Let's get right to it.
Section 1. The Civil Engineering Academic Roadmap, from fundamental theories to high-tech BIM labs. Okay, let's dive into how your university studies actually set you up for success out there in the corporate and industrial world. Your 4-year degree shifts gears pretty rapidly. Year 2? That's where real engineering begins. You hit the core physical foundations, things like fluid mechanics and surveying. Because, well, you have to understand how water flows and how to map the earth before you can even think about building on it. Then, in year 3, the focus pivots heavily into critical structural design. Think reinforced cement concrete, steel structures, and geotech. By year 4, it's all about finding your niche, mastering project estimation, and knocking out that capstone project. As your mentor, here's my biggest piece of advice. Do not sleep on years 2 and 3. They are the absolute backbone of your entire career.
Now, having all that theoretical knowledge in your head is great, but your technical toolkit, that's your ultimate weapon for translating textbook knowledge into real-world value for a company. You absolutely have to master AutoCAD and Civil 3D for drafting, and for structural load analysis, tools like STAAD Pro and ETABS are pretty much the gold standard. Plus, knowing how to navigate industry reference books and regulatory codes, like the IS codes or Euro codes, is literally what separates a fresh student from a highly hireable top-tier professional.
Moving on to Section 2. Acing your campus placements. Let's talk strategies for securing that crucial first engineering role.
Transitioning from the classroom to landing that first job usually means surviving a campus placement process, which kicks off around your 3rd year. It generally follows 3 pretty rigorous steps. First up, companies are going to hit you with written, quantitative, aptitude, and logical reasoning tests. If you can pass those, you're on to the technical interviews. And finally, you wrap up with HR evaluations and group discussions. You're basically required to balance sharp logical reasoning with rock-solid engineering fundamentals.
So, you might be wondering, what do they actually grill you on in those technical rounds? Well, spoiler alert, interviewers usually care way less about complex multi-page mathematical derivations. What they really want to see is a strong, intuitive grasp of your core subjects. They want to know that you fundamentally understand the strength of materials, RCC, steel structures, geotech, and construction management. But most importantly, they want to see that you know how to apply them safely out there on a real-world site.
All right, Section 3. Choosing your career path. Government, consulting, or contracting.
Once you've got those offers in hand, you're faced with a major decision. Where do you want to spend your days? A gleaming corporate office or a massive industrial site? Let's break it down. Consulting gives you incredible direct design experience and project management exposure. But, fair warning, it often comes with the intense pressure of billable hours and pretty tough schedules. On the flip side, government roles provide amazing work-life balance and rock-solid stability. The trade-off there is that the day-to-day work can sometimes get a bit non-technical and repetitive over time.
Alternatively, contracting throws you right into the dirt, literally. It immerses you in field experience with long hours, but usually great pay. It's super high energy. But keep in mind, spending too long in contracting can sometimes make it a bit tricky to pivot back into office-based design later on. Office design keeps you indoors, hones your software mastery, and gives you a very clear, structured pathway to earning that highly coveted professional engineer, or PE license.
Section 4. Navigating the first 2 years. We're talking about balancing field experience with your long-term goals.
Honestly, your first 2 years on the job are basically a paid exploration phase. The choices you make right here will totally define your trajectory. We actually found this fascinating real-world dilemma from our sources.
Should you sacrifice long-term design experience for a high-paying field job straight out of college? One recent grad faced this exact choice, taking a solar farm contractor job for almost double their base salary so they could save aggressively. But they had to weigh that huge short-term cash injection against their long-term progress toward becoming a specialized professional engineer. It is the classic struggle of short-term money versus long-term career capital.
Whatever path you end up choosing, do not underestimate the sheer power of field experience. Taking a field role early on is unbelievably valuable. Why? Because once you actually understand real-world construction site procedures, safety protocols, and how things physically fit together, your office design work becomes infinitely better. I mean, you simply cannot design a great building if you don't know how it actually gets built in the real world. So how do you thrive and build that long-term survival guide? Actively seek out employers who have solid engineer in training or EIT development programs. Network constantly. Go to those ASCE events. And here is a massive pro tip for me. Do not rely solely on your direct supervisor for mentorship. Go out and find experienced peers across the industry. Also remember that civil engineering is a massive team sport. You've got to learn to communicate effectively with architects, mechanical engineers, and electrical engineers. And above all else, be willing to grind and adapt to all sorts of different personalities.
And finally, Section 5, Global Salaries and Future Trends. Let's look at the macroscopic rewards of civil engineering. All right, we've talked plenty about the grind, so let's talk about the payoff. Let's look at the incredible global compensation dynamics of this career. In the United States, the median annual pay for civil engineers is sitting pretty at nearly $100,000. A huge driver for this is the massive federal infrastructure investments going on right now. Society constantly needs to upgrade aging bridges, roads, and water systems, which essentially bulletproofs your value in the marketplace.
But hey, that number is just an average. Compensation actually varies wildly depending on your sector. Specialized structural roles, aerospace-allied positions, or even certain nonprofits can command significantly higher premiums compared to standard state government jobs. If you master advanced software, like BIM or structural analysis tools, early in your career, you can slingshot yourself into those higher salary brackets so much faster.
And don't forget, this degree is basically a global passport. Mobility is a huge perk. Hubs like Dubai offer massive tax-free salaries, boasting a 250 to 300% starting premium over domestic markets, just for handling high-density, complex structures. Meanwhile, countries like New Zealand are offering highly lucrative starting roles completely driven by their strict green infrastructure and sustainable construction mandates. Your skills literally translate across borders seamlessly.
Before we wrap this up, I want you to remember this golden piece of advice from the veteran engineers in our sources. They say, your early career is entirely an exploration phase. Just get experience whether it's site work, design, or inspection. You'll learn what you don't like as much as what you do. Honestly, that hits the nail on the head. Embrace the grind, find yourself a great mentor, and never stop learning.
So as you step out into this incredibly innovative, collaborative, and absolutely essential industry, I'll leave you with this ultimate question. Armed with this blueprint, what kind of infrastructure will you build to leave your lasting mark on the world? I really hope this explainer helps you build a phenomenal career. Thanks so much for learning with me today.